Today we're doing section 1.7, day 2, and we're going to focus on combining functions by adding, subtracting, multiply, and dividing. So for our first example, you're going to be given two functions. So that is that f of x is equal to 2x minus 1, and that g of x is equal to x squared plus x minus 2. And the first calculation we're going to talk about is adding. So f plus g. And it really is as simple as it sounds. You take your f function, which is 2x minus 1, and we're going to add it to my g function of x squared plus x minus 2. And when I look at this, the only terms I can combine are 2x and x, and then my numbers, my constants. So I have x squared plus 3x minus 3. And this is our final answer for adding. To kind of tie in what we did yesterday, our domain is negative infinity to infinity because there is no fractions in this problem. So going on to subtraction. So for letter B, we want you to do f minus g. So to do that, we have 2x minus 1 minus the quantity of x squared plus x minus 1. So here we're going to have to distribute that negative in. So this first quantity can, parenthesis can drop because nothing's being distributed to it. The second quantity will distribute that negative in. So all the signs are going to change. And then I can combine my x's and I can combine my constants. So I have a negative x squared plus x. And then those, actually, you know what? I copied that wrong. This should be minus 2. So that'll be plus 2, and then I'll have a plus 1 here. So that's what I get when I subtract them, and again, the domain is negative infinity to infinity because there's no fractions or square roots. So next, moving on to multiplication. So for this one, we're doing f times g. So I have 2x minus 1 times the quantity of x squared plus x minus 2. So if you're a boxer, you would fill it in as a 2 by 3, like so, and your values go on the outside. So you would go ahead and do that and find the inside. My distributors, you distribute that 2x to the first terms and then negative 1 to all three terms. So if I distribute 2x, then I'll get 2x cubed plus 2x squared minus 4x. And now I'm going to work on this negative 1. So I'll have a negative x squared minus x plus 2. And notice when I went there and distributed, I stacked it like this and made it organized, so it's a lot easier to combine like terms. So I get 2x cubed plus x squared minus 5x plus 2. So that's the final answer for multiplication. And again, the domain is negative infinity to infinity because no fractions or square roots. So the last one is division. So I have f divided by g. So I take my 2x minus 1 and divide it by x squared plus x minus 2. So this is actually unique in the fact that the problem itself is done. This is the answer for division. You can't simplify it. But the domain becomes the part where you have to do more work. So I need to find my domain restrictions, and I do that again by setting this equal to 0 and solving. So to solve this, I'd figure out 1 multiplies to be negative 2 and adds to be 1. So it's a 2 and a negative 1. So I'll have x squared plus 2x minus x minus 2. And again, those of you who do the box method, these are your 4 terms that go inside the box. So we group them. So I can take an x out of the first quantity, and I can take a negative 1 out of the second quantity. So this will become x minus 1 and x plus 2. Which means x cannot equal 1 and x cannot equal to negative 2. So our domain is negative infinity to negative 2, union negative 2 to 1, union 1 to infinity. And remember that domain, you're trying to tell me what values you can use. You can use every value except 1 and negative 2 because that will give you an undefined answer. So the last one I want to go over is a unique case. We're just going to talk about the addition part of it. So f of x is equal to the square root of x plus 3, and g of x is equal to the square root of x minus 2. So if I were to do the addition, again, not much work is required here. I get the square root of x plus 3 plus the square root of x minus 2, and I can't really do anything. So that's the answer. But the domain is where we have to do more work. So we need to find a domain that kind of works for both of these. It needs to be in common for both of them. So this statement right here, if I said x plus 3 has to be greater than or equal to 0, I would get the statement that x has to be greater than or equal to negative 3. And this statement will say x has to be greater than or equal to a positive 2. So we're going to think about this on a number line, and then we'll write our domain. So here's 0, here's negative 3, here's a positive 2. So the first statement says everything has to be greater than or equal to negative 3. The second statement says everything has to be greater than or equal to 2. So if I have to combine these two thoughts, the smallest value I can use is 2 and up. So my domain would be from 2 to infinity. Again, all of these values in this section right here, from negative 3 to 2, would work here in that first statement. But if I plugged any of those values into the second square root, I would get an imaginary number. And you can't add a real number plus an imaginary number. So again, you have to restrict values because you're trying to tell me what values you can use in this function and what values would be defined. So that's all for today. We're going to pick up with that tomorrow.